A shining beacon of peace, progress and prosperity in the Arabian Gulf, Qatar is one of the fastest growing countries in the world. Since the discovery of oil in 1949, Qatar has capitalized upon its abundant hydrocarbon resources to build a nation that proudly celebrates the past while leading the way into the future. Driven onward by the inspiration of its leaders, the nation continues to reinvent itself to meet the needs and aspirations of its people in the 21st century. Under the wise leadership of His Highness the Emir Sheikh Tamim bin Hamad Al Thani, Qatar is growing from strength to strength to emerge as a social, economic and political force to be reckoned with on the international stage. Guided steadfastly by the National Vision 2030, all of Qatar is working together to strengthen the 4 pillars of the manifesto. By addressing the social, economic, environmental and human development needs of the nation, Qatar Petroleum is proud to play a central role in helping realise that vision of transforming Qatar into a sustainable, knowledge-based economy of the future. Established in 1974, Qatar Petroleum is the state-owned hydrocarbons producer that is directly responsible for all phases of Qatar's oil and gas industry. Its activities, including subsidiaries and joint ventures, cover exploration, drilling and production, transport, storage, marketing and sale of crude oil, natural gas liquids, liquefied natural gas, refined products, petrochemicals and fertilizers. Working together with the world's major oil and gas companies, Qatar Petroleum is reinforcing Qatar's position as the world's largest LNG producer, as well as petrochemicals capital of the world. Qatar Petroleum's operations and activities are conducted at numerous onshore locations at Dukhan, Mesaieed and Ras Laffan, as well as offshore areas, production stations and drilling platforms in the Arabian Gulf. This is Dukhan, one of Qatar Petroleum's key onshore sites for the production of crude oil, associated gas, condensate and non-associated gas. Located 80 kilometers from the capital city of Doha, the Dukhan field lies on the western coast of the Qatari Peninsula. The field, which has been meticulously developed since the 1940s, measures about 80 kilometers by 8, with a maximum capacity of 335,000 barrels per day. It has more than 750 oil, gas and water injection wells, which are connected by a network of more than 4,200 kilometers of piping. The Dukhan field is split into 3 sectors: Katia in the north, Jaleha Diab in the south, and Fahahil in between. The liquid stream from the wells in Dukhan field is fed to 7 degassing stations, which separate and stabilize the oil and gas to meet saleable tank pipeline specifications. The degassed oil is sent on for final storage and onward pumping to Mesaieed for shipping. Part of the degassed crude oil is processed in QP refinery at Mesaieed to meet the refined products requirements. The associated gas, however, contains heavier hydrocarbons which are condensed and separated, or stripped. The recovered, stripped heavy hydrocarbon stream, called NGL or natural gas liquids, is pumped in liquid phase as feedstock for petrochemicals production to Mesaieed. The stripped associated gas is also sent to Capco in Mesaieed for use as feedstock. This task to recover NGLs from associated gas falls under the Fahahil stripping plant. Located just south of the Fahahil main station, the stripping plant received dehydrates associated gas from degassing stations that serve the Dukhan field. The plant is designed to recover the national gas liquids in the stream by compressing and chilling the gas, so that the liquids are condensed for easy extraction. A key component of the plant is the refrigeration system, which allows the gas to be chilled to the required temperature. These 2 open water ponds supply the humidifying water for the plant's 2 fin fan coolers that are mounted right above the ponds, one for each of the plant's 2 process trains. Water lost through evaporation is replaced by the freshwater makeup supplied by Dukan desalination plant. Troughs distribute the water to angled slats. Fin fans mounted atop each bank draw air across the cooler's coils. The remaining water is circulated back to the ponds, which are treated to prevent corrosion and the growth of biological organisms. The gas passes through the pipeline separator, where most of the hydrocarbon liquids and water are separated. The recovered hydrocarbon liquid from pipeline separator is sent on to the Fahahil main degassing station. Next, a section scrubber knocks out any hydrocarbon liquids that may have formed in the gas streams entering the vessel. The gas then leaves the scrubber via a demister toward the suction of the booster compressor, which pressurizes the gas to about 545 pounds per square inch gauge before delivering it to the stripping trains. This is achieved without creating a high back pressure on the incoming pipelines. Once it enters the 2 parallel gas processing trains A and B, the gas is first cooled by simple heat exchange with the cold outgoing gases. Refrigeration systems in each train further chill the gas, resulting in partial vapor separation in the fluid. From the booster compressor, the gas is routed to the inlet gas cooler, then onto the inlet gas exchanger, and finally to the gas liquid exchanger. Condensed natural gas liquids are collected from the bottom of the vessel. By this time, approximately 10% of the NGL remains non-liquefied. The stream is then fed into the gas chiller as cold gas. Immediately upstream of the inlets to the inlet gas exchanger, gas liquid exchanger and the gas chiller, glycol is introduced into the stream to serve as a dehydrating agent. The gas liquid mixture passes to the cold separator, where the remaining liquids are extracted from the stream. Most of the glycol in the mixture settles out in the vessel boot at this stage. The separated natural gas liquids, along with some entrained glycol, passes to the glycol coalescer for the remaining glycol to be recovered for purification and reuse. The stripped gas from the separator is returned to the inlet gas exchanger, serving as a cooling gas for the incoming stream of gas to the plant. Finally, most of the 300 million standard cubic feet per day of processed gas goes to the government gas header to serve as feedstock and fuel. A small portion is diverted to the Fahahil gas header for local plant use. The remaining liquid passes to the cold liquid flash drum, where very low pressure induces rapid flashing of the liquid to make separation easier. The collected NGLs are forwarded to the gas liquid exchanger in preparation for piping to the Mesaid fractionation plant. Some of the NGLs may also be re-injected into the gas cap of the production field if and when it is required. Back at the plant, the cold gas goes on to cool the propane in the flash drum, which is used as the cooling medium in the gas chiller. Here, the pressure of the propane is reduced so that some of the liquid vaporizes, thereby cooling the mixture. The propane refrigeration system supplies the cooling to lower the process gas temperature before the gas enters the cold separator. The propane is recovered and recycled continuously during operation. After making its way through the flash vapor exchanger and 2 stages of compressors and discharge coolers, the recovered gas finally returns to the plant's main gas export line, mixing with the output product from the inlet gas exchanger. The incoming overhead 3-phase 33 kV power supply is stepped down to 3.3 kV at a substation for plant use. This is further stepped down to 415 volts for general power, and then to 240 volts and 110 volts for small power and lighting. In the event of an electrical power failure, an emergency diesel generator is capable of supplying power to mission-critical services. An instrument air system supplies clean dry air to operate the pneumatic valves and equipment on the plant. The system is comprised of instrument air compressors and 2 dry packages that supply a common distribution header. While one compressor is on duty, the other remains on standby. Detection of low instrument air pressure activates an alarm in the control system, but does not initiate a plant emergency shutdown. The distributed control system allows for control and monitoring of a facility by an operator from the control room, supported by an engineering workstation for programming changes and graphical monitoring of the running and set point parameters across the plant. Alarms as well as fire and gas protection systems all interface with the distributed control system. Each section within the plant is equipped with its own emergency shutdown facility for mishaps or other emergencies. A total plant shutdown may also be triggered, in which all zones are immediately pulled offline. After a process shutdown, emergency shutdown, or an emergency depressurization, all shutdown and control valves must be manually reset locally at the valve solenoid before operations can be resumed. Fuel gas to power the turbines and glycol burners is drawn from the process fuel in the stripped associated gas header. It is also used as a utility gas to fuel the flare pilots and igniter systems, as a purge gas through flare and blowdown headers, and as a starter gas to power the starter turbines. Flares are maintained to burn off excess vented gas from vessels throughout the plant. A high pressure header and a low pressure header accumulate vented gas from various parts of the plant to be fed to the flare. Relief valves and emergency systems divert gas safely to the flare for burning in case of any plant emergency. The liquid blowdown header collects from the bottoms of various vessels to be fed to the burn pits. The vent header is used to vent off to atmosphere from vessels, compressors and exchangers across the plant during depressurizing. The Fahahil stripping plant is designed and engineered to meet or exceed the highest international safety standards prescribed for a plant of its type. It features state-of-the-art safety systems and fail-safe measures to provide the highest level of protection to the personnel working in the plant, as well as the environment. Its processes, output and flared gases are carefully monitored to ensure the smallest possible footprint, so that Qatar's economic progress does not come at too large an environmental cost. The Fahahil stripping plant represents a key infrastructure link in Qatar's hydrocarbons chain. The gas and NGLs separated at the facility serve as the feedstock for many of the downstream petrochemical facilities located in Mesaid. In addition to being used as a fuel and exported as LNG, much of the gas is also processed further into polymers, chemicals and fertilizers to derive additional value from the national hydrocarbon resources, which help turn Qatar into one of the world's largest exporters of high-quality petrochemical products. Qatar Petroleum is proud to own and maintain the state-of-the-art facility in the Dukan field. Under the team's expert care and maintenance, the Fahahil stripping plant will continue to serve the interest of Qatar and its people many decades into the future.